Hello, incredible students. The last major focus of chapter 1 deals with how do we classify matter? And on page 14 in your unit packet, there's this chart. I also, just to expedite this review, I have some terms already defined for us. So I'll be alternating between these as we talk through this. So anything that has mass and takes up space can be most simply divided into a pure substance or mixture. Pure substances cannot be physically separated. If we would think of some examples of physical separation, they are methods that do not chemically change our substance. So, for example, if I have my pile of markers here, well, I can physically separate them. I could pour sand and water through a filter and catch the sand. We could take Kool-Aid and evaporate away the water and then retain the sugar, dye, and flavoring. Those are all physical means. You cannot take forceps and pick apart an element. We know elements are specific atoms. So, for example, if we have a helium atom, what makes that helium is it has 2 protons. It has 2 electrons if it's neutral, and the most abundant form has 2 neutrons. We know made of protons, electrons, and neutrons. Well, you can't take an atom of helium and with forceps separate these subatomic particles. We can't run this through a filter and separate them. That's what we mean by separate into component parts. Elements cannot be physically separated, but they also cannot be chemically separated. So we can't perform a chemical reaction and separate out the protons, the neutrons, and electrons. Elements are specific types of atoms. So we have our whole periodic table to rely on to remind us of the specific elements. And we'll talk about to come, depending upon, really, we can use the periodic table to help us. Placement, there are 3 categories of elements: metals, non-metals, and metalloids. Whoop, I am so sorry that I'm messing up where this is, and metalloids. But I will do a separate video on that. So we cannot physically or chemically separate a substance, then it's an element. And, elements, specific types of atoms, that's how we make nature, right? Matter is made of atoms. Those are the basic building blocks. So thank goodness it's not easy to break them apart. If we take 2 or more elements and chemically combine them, so we're having some kind of relationship occur because of their electrons, ionically, covalently, or metallically, then we have a compound. So a compound is 2 or more elements that are chemically combined. Now, we can't physically separate a compound. For example, sodium chloride. We cannot pick apart the sodium and chloride ions with forceps. We can't run it through a filter. We can't heat and just release chlorine like we can evaporate away water. So compounds cannot be separated physically, but they can be separated chemically. Now let's go to mixtures. So the difference between a mixture and a pure substance is mixtures can be physically separated. So the sand in water mixture, fruit salad, you could actually pick apart your favorite things or separate out what you don't care for. A lot of food items are great examples of mixtures that we could physically separate. you can actually separate if the marker dye is made of different shades of different colors. They're just physically combined. And we could actually separate them with a method called chromatography, and we will learn that. You often experience that. Let's say if you have a drawing and then some water gets on your paper, and then this smears and sometimes evolves into different colors. Well, we're just physically separating them. All right. Something about a mixture also, it can be physically separated because the pieces are physically put together. So if we think of Kool-Aid, when we combine water with sucrose and the Kool-Aid packet that has the dye and the flavoring, well, water remains water, even though the sugar is dissolved in it. The dye remains the dye. They just all contribute their individual properties to make Kool-Aid what it is. So even though they're together, they retain their own personal characteristics. However, whenever we combine elements, if they're chemically reacted, they have a totally new set of chemical characteristics. Of course, a chemical process has occurred. For example, solid sodium element, it's actually a metal. It is so reactive with water that we categorize it to be explosive in water. So you could never place elemental sodium in your mouth. It's silver. It's a very soft metal, solid room temperature and pressure. Well, if we react that with chlorine gas, this is pale yellow, it is toxic, even in very small amounts. Well, if we combine these chemically, we form sodium chloride, an ionic compound that is a white crystalline solid, soluble in water, and we need this in our diet to live, to operate healthily. So even though this is made of sodium, when sodium combines chemically with chlorine, totally new properties result. Totally, it's a chemical change. All right, let's go back to mixture. Well, mixtures can be further classified to be heterogeneous or homogeneous. It has everything to do with consistency. Kool-Aid. To the naked eye, you cannot see layers. Like if we had sand in water, you can see the sand sink to the bottom. I mean, even if you give it a stir, you can see the individual sand grains. Well, Kool-Aid, your 10th, your 500th sip tastes the same because the ingredients are equally distributed. That's homogeneous. The prefix homo means same. That is the same composition or distribution of your components throughout. So if we looked under a microscope, it would be not perfectly, but pretty equally distributed. Heterogeneous, there's differing composition throughout. If we think a bowl of Lucky Charms, every scoop could have, this scoop could have one marshmallow, another a couple of marshmallows, more milk, not enough, and so on. So that would be a great example. Now, there are some samples that to the naked eye may be hard for us to tell. So I want to make sure that we're clear that milk is a heterogeneous mixture. No matter whole, 2%, 1% skim, milk is homogenized. That does not mean it is homogeneous. Homogenized, and that is, it's treated to break up the fat globules as much as possible, even in skim milk, so that it doesn't separate with time. But if we look at under a microscope, even skim milk, we'll see a little bit more fat globules here, maybe a little bit, but it's not consistent throughout. Tap water tap water is not just H2O. It has other things added. But once you have your glass of water, the 10th sip, the 50th sip, all the same. And if we could look at it under a microscope, everything would be equally distributed. All right, so these are the basics. I did have some other terminology here. Now, I just want to make sure I know I said it, but we say an atom is the basic building block of matter. We put together atoms to make our world, to make compounds, and then those compounds or other elements can combine to make mixtures, and so on and so on and so on. An element is a specific type of atom, like carbon, like silicon. So just like student, well, that's kind of generic, but then there can be Billy and Sally. That would be more like an element is to an atom. And here's compound, and then a little bit more about mixtures. I also have some just common examples if you want to pause and take a look at this. Now, if I give you a list of substances, we know if something is an element and can prove it by looking at the periodic table. So you can get confirmation. So these are all, of course, names of elements. A compound. I will always provide us the IUPAC chemical name. And the way we name chemicals reveals their composition. So if you read through these, you can hear or read in the name that it's made of more than one element. So I have the formulas here, but if I just gave you the names, can't we classify them easily as compounds? And then here's some examples of homogeneous and heterogeneous mixtures. On page 16 of your packet, there is a checkoff list of some other examples. So we can definitely tell things are elements by checking them on the periodic table. And so copper, element symbol Cu, oxygen O, helium He, argon Ar. We'll get to know these symbols. But if you're wondering, argon, just check the periodic table. Check out. So silicon dioxide, can't we hear it's made of silicon, oxygen? Let's see. Sodium chloride. Can we hear it's made of sodium and chlorine? Distilled water. Now distilled, that means just H2O. Just H2O, compound. Tap water, other things are added for our tooth health and for preservation. Fluoride compounds. We have minerals from the source of the water, Monongahela River in the case of Peters Township. So homogeneous mixture. Sodium bicarbonate will not give us common names or nicknames. I will give us the appropriate chemical names. Can't you hear it's made of more than one element? Okay, now, as far as mixtures, sometimes I need to qualify it more. Coffee. Are we talking about a cup of coffee with sugar and cream? Are we talking about a cup of just brewed coffee? Just brewed black coffee, homogeneous mixture. Water has been passed through grinds that have extracted out the wonderful ingredients that deliver what we call coffee. And your 5th sip and 18th sip, the same. Now, as soon as I put cream in this or milk, it becomes heterogeneous because cream and milk are heterogeneous. Mixed salad, easy. Tap water. A pencil. Clearly, you can see there's different parts. Talked about Kool-Aid. Now, fresh squeeze, there's going to be some bits of orange pulp. Bread, even if it's whole white, you still have the crust versus the inner part. The crust has just less water than the inside, but still it's different. Sand, I would make sure that we knew, it's from the beach. So if you would take a handful of beach sand, it's going to be maybe more shells in one part than another. So definitely different. We know that. We know that. Talked about milk. So that gives us a good idea of what are the classifications of matter. And then if you're given a sample of them, how could you categorize it? The questions on page 17 are excellent to really think your way through yourselves, to really test your understanding of what the different classifications of matter are.